Hello, everyone. My name is Steve Hanley,
I'm Rob Parent.
and we're from the NDAC team, and we're going to show you how to get started in Google Colab to do some data analysis in Python. So let's get started. I'm Googling Google Colab, and you can come in here. It's basically a Google Doc. So we're going to make a new notebook, but it's for a new Google Doc for executing and writing Python code. So we're going to save this as intro to Colab, and we'll get started. Now, nice thing, these are the Jupyter notebooks basically, so you can have code and text and the outputs all in line. So we're going to start by, and this helps you build basically a test report, which is what our purpose is today. So let's write down before we get started, what are we trying to do? And this is in markdown text, so I'm putting a hash space, and then that basically makes it a header. So now, what are our goals, Rob? We have some vibration data.
Yep, we have some vibration data. We want to import it into Colab, and we want to pick out an area of interest. We want to do a little bit of analysis on it and share with our teammates.
Okay. Frequency analysis. Share results. All right. So now we have a nice little overview of the goals of the project. And the first thing we have to do before we can actually import the data is install the libraries we need to use. So for this analysis, we want to use the NDAC libraries. I'm going to do pip install NDAC. And I don't know if there's any other libraries we need. We can also use Kaleido to save Plotly images or Plotly plots as images. So I'm going to say exit here because after I install the libraries, I want to force a restart of the runtime. So as that's going, I will start preparing other sections because I'll build this into a nice report. So we're going to say the first section up here we install the library. Install library. Here we are going to load in the data. All right. So installation has worked. You see that we've installed the NDAC library, and we've installed all the dependencies it has, which include SciPy, NumPy, Pandas, things like that. How are we doing?
Doing great.
Okay. So the next step is to load the data. Now this is where Google Colab. I love everything about Google Colab except this part, which is accessing our data. So Google Colab is a cloud-hosted notebook. You're writing and executing Python code. It's easy to share. You don't have to install anything. You're just on your web browser, so it could be on your machine, at home, at work. It could be on your phone even. But the only downside is because it's in the cloud, in order to access any data that you have saved locally on your machine or on your company's network, you have to load it into a cloud location.
That's right.
So that could include Google Drive. It could include other sources, but when we're in Colab, we can just import the file here. So we're going to do that right here. I don't know if you're seeing the screen, but in my downloads, did I save this? Dwell test. So I'm importing my CSV called dwell test. And Google Colab is reminding us that once this runtime will get reset, and we will lose this data because it's only saved kind of locally and temporarily. So that's the only downside. So now you should see it on the left hand. It's in here, and we're going to load this in. So we're going to use the pandas library to do this. So I'm going to import pandas, and then I'm going to say, what should I call my data? Data?
Yeah, we'll call it data.
We'll call it data. Data equals pd.read CSV, and then I'm going to put in the file name of my data. Now my data frame is set up. It should be set up with the x-axis, the first column being time, and then the subsequent columns being the real vibration data. So I'm going to pass in the variable calling index call equals 0. This is saying force the first column to be my index. I'll show you what that means in a second. All right, and then I'm going to print out data. Let's see if this runs. Okay, good.
That's great.
So this is our data frame. It's a pandas data frame. This is the index. That's the time index as seconds, and then my channels here of X, Y, and Z. Now, I'm a little bit of a stickler for, I'm generating reports here. I don't necessarily want X40G to be included in my plots. I don't think my customers and my internal people care about that. So I'm going to rename the columns here. Maybe I know that X is, transverse, Y is longitudinal, whatever. But I don't, right now I'm just going to say data.columns equals, I'll just make it X, Y, and G, X, Y, Z, or?
Yeah, I think for purpose of this.
So this is a list, and now if I reprint it out, it's a simplified column header. So you could change your column headers to be whatever they want. All right, so we got through our first step, which was load the data. The second step we want to do is plot it.
Yes, plot the time series, and see what we get.
All right. So I'm adding another section. I'm going to import the Plotly library to do this. Now, oops. If you notice, there is about 100,000 data points, or 100,000 rows, and there's 3 channels, so there's nearly 300,000 data points.
Yeah.
Plotly can do this, but it's going to plot every single figure. So we're just going to do fig. I'm just going to do px.line, so plotlyexpress.line plot, and then I'm just going to pass in my data frame, and this should work. But it's going to plot all 300,000 points, which might make my browser upset. It didn't, so we're okay. And you'll see here if I zoom in, it's pretty responsive. Here's my 300,000 points, and there's some interesting, we'll get into the, processing and analyze data in a second. But the first thing I'm calling out here is it just plotted all 300,000 data points. And that can be a little bit intense if I have longer time series. This is only 25 seconds worth. So I'm going to show another function we have in our library to make this a little bit easier. So I'm going to actually remove this output for now so my JavaScript doesn't kill me later. And I'm going to use the NDAC library, so import NDAC. And I'm going to set, so NDAC.plot.utils. Oh, I forget what it's called. It's set theme. Let's see if this works. No. Util? No. All right. Well, this is a good example. If you guys see my screen, I'm going to docs.ndac.com. And hopefully this is coming through. You guys can see this. I think you can. When I go back to the other tab, my head kind of appear? My head comes back. We're back. But I think when we're over here, you guys are seeing this. Oh, here we go.
There we go.
So this is a good example. All these functions in the NDAC library and every function we use, there's documentation online to see, how to reference those files. So we're trying to use NDAC.plot, and what is the plot we're trying to do? We're just trying to use utilities to find theme. Okay. So
there we go.
There we go. Now we're good. All right, so I want to use a figure NDAC.plot. Rolling min max envelope. And I'm going to pass in the data. Let's see. Google Colab should give me some. I'll come back to it over here. I think the here we go. Desired num points. Let me explain what this function is doing while I'm typing this out. It's basically plotting bars from the min to the max of a long data set, but kind of segmenting it. So if I say desired num points equals 1,000, it's going to reduce my 100,000 points into 1,000 segments and plot from the bottom to the top a bar for each one of those. And the benefit of this is you're only plotting 1,000 points, 1,000 bars. But when you're zoomed out, it will look basically the same if you remember when I plotted all 100,000 points.
Yeah, very useful.
So I'm also going to do plot as bars equals true. And I think that's all I need. So we'll do fig.show. See how we look.
Yeah. So it looks the same from this view. If you zoom in, should be able to see. Looks almost too similar. There we go.
Oh, it's right. The only thing I'm confused on is I thought I changed the theme. Oh, I did define theme, and I should have done set theme. I think. Yes.
Yeah, that sounds right.
All right. Well, that's good. We will redo that. We'll do set theme, and then rerun this. There we go.
Nice.
And we have my nice NDAC theme, nice colors. I like that. And plot. There's other themes in Plotly you can play around with. But if you remember, this is only plotting 1,000 data points, but it looks basically the same as if we were to plot all the data points as you saw before. You didn't even know. You thought it didn't work at first when we first saw it.
Yeah,
so that's good.
That's similar. Yeah.
There's one other parameter I'm going to specify here, which is opacity. Opacity?
Opacity.
Is that right?
Sounds right.
So now this is nice, and now I can actually see when I plot without an opacity of less than 1, the order in which you plot matters. If you saw before, the z-axis was plotted over the x and y, so you couldn't actually tell what the x and y was. So this is nice. You can kind of see that a little bit. But this is Plotly, so you can turn things on and off inside and you can zoom around. But if you remember, if you zoom in here, we're pixelated because we're only plotting the 1,000. But I'm going to do one other fun thing here before we get into the data analysis. Is I still, as an engineer, I like that I didn't have to plot all 100,000 points, but I want to see the time, see what that kind of sine wave looks like, or a bit of the raw data in the area.
Yeah, without having to plot out everything.
Yeah. So I'm going to use import plotly.graphObject as go. And what I'm going to do here is I'm going to add to this figure a bit of the raw data from 10 to 11 seconds.
Yeah, an overlay of just that.
Yeah.
That specific section.
So for C in data.columns, do you know what I'm doing right now?
What are you doing right now?
Well, this is a for loop, and I'm just going to loop through. Remember up here we specified our columns X, Y, and Z. So I'm going to say in Python, C is representing now a column. It's my variable that's my column name. And so when I say here data, and I'll just show you guys, and I'll just do print C. So you guys will see what's happening. So it's
right. Yep.
Okay. You understand what's going on?
Yes. Yeah.
Should you explain it?
Yeah, I think it's for. Oh, should I explain?
Yeah. Well, as I type this out, you explain it.
You're looping through. I mean, I get what you're doing generally. I think so. You're looping through the data columns. Let's see here.
Well, now I'm going a little bit further, but I'm saying before C is now a variable that every iteration of the loop is referencing a different column in my data frame.
Yep.
All right, so now I'm going to use this loop to add a trace. So figure.addTrace, and this is go.scatter. You guys can look into this at your own leisure, but there's all these different Plotly plot types, and I'm making a scatter plot here. So y equals data c dot, oh, actually, first thing I'm going to do is temp data is going to equal data C, so the column that I'm focusing on, and the area from 10 to 11 seconds.
What are you doing there?
I will. So every time I go loop through this now, my first loop, the column C or column X, and from time of 10 seconds to 11 seconds. Then the second loop, I'm column Y from 10 to 11 seconds. And the third loop, I'm column Z from 10 to 11 seconds. I'm just making this a little bit easier. And so now I'm going to say add trace and use temp data dot index and temp data. I think I should just be able to do that. And I'm going to name it equals C plus at center.
Mhm.
And then I think I'm going to say mode equals lines. I don't know if this is going to work. We'll try it. So remember, I'm making a scatter plot, so I could do, I think it's points plus lines, or points, Am I making any sense?
I think it'll be a little more clear when it's graphed out here.
Sweet, it worked. So I took the figure we had above, and I just added to it at center from 10 to 11 seconds the raw time history. Now, if I zoom in here, you can see that. And we'll just focus on one channel. This is the x-axis at center. We'll focus on a little more. Here's Z. But the nice thing about doing it like this is I can zoom out and see kind of what my aggregate is. And as I've zoomed in, I have a better idea of, I still have the raw time here, time history, so I can dive deeper.
Yep, and everything still loads quickly.
Yeah. Right.
Still easy to navigate.
All right. How are we doing? We're 15 minutes in. That maybe was a bit deep, but that's okay. All right. Next step is we're going to do some actual analysis. So frequency analysis. What do we want to do, Rob?
Well, you want to see what the dominant frequencies are for that time range that you picked out.
All right. So we're going to generate an FFT, and we're going to say use the NDAC library again, .calc.fft. There's a few different functions here. We're going to use aggregate FFT. Aggregate FFT lets us specify a bin width. So it lets us basically do some windowing and averaging to have a nice clean FFT. Normal, if you do a regular FFT, your frequency resolution is defined by the length of the time you input it. Mm-hmm. So here we're going to say we want a FFT from the time data. We're not going to do just that 1 second. We're going to do from 5 seconds to 15.7 seconds. Mm-hmm. Does that make sense? So 5 to 15.7. And we'll say bin width equals, what type of resolution do you want in the FFT?
I think we want it pretty high. I think maybe it's just worth specifying you don't want to pick too large of an area for the FFT.
Yeah. We'll do 0.25 hertz. 0.2 hertz.
Okay.
All right. And then we're going to print this out, see what this looks like. So we have an FFT here. First is at 0 hertz, then 0.2, 0.4, etc., all the way out to 10,000 hertz. And now we can plot this with Plotly Express. So px.line. I'm going to pass in the FFT. That's all I really have to do there. I can also say I'm going to do update layout. To say x-axis title text equals frequency hertz. Y-axis title text equals acceleration g. Do you want to add a title to the plot?
Well, I guess what are we calling the overall file? Calling it?
I think we'll call it dwell test.
Yeah. Okay.
We're going to name this figure fig FFT, and so then we'll make an overall title as dwell FFT. Oh, what'd I do? I forgot a comma. I need to show it. There's our FFT.
Nice.
So if we go back to our time history, if you look in here, I'll just kind of look at the z-axis. You could tell there's a very obvious single tone here, but if you zoom in on it, there's the kind of the ripple on top of that. So that's what we're seeing here in the FFT. The large tone is this nearly 2G 33.4 hertz major tone, but then up here you see it, especially in the 1300 hertz range, there's something else going on that's being added on top.
Yes. Yep.
All right. So we have done our analysis mostly. Now we need to share it.
That's right.
All right. So what do you want to share? Well, the nice thing is we could share this whole thing. So I can make this this Colab notebook a,
Yeah, like any other
Okay.
Google Office. Is it Google? What's the
Google Docs.
Google Docs? Yeah, like any other Google Docs file, you can share it.
And we'll put this, I guess, in the video description too, so you guys can see this and follow along.
Mm-hmm.
And you'll be able to see that. You can go to it. You don't need to log in, and you'll see all the plots that are shown here. So that's one way to share.
And we'll also want to show, if you're not trying to show your coworkers everything, you just want to show them the graphs that you worked on.
Yeah.
The FFT at the end, or
yeah. So let's also export a couple plots. So we have two major plots we want to share: the FFT and the time history. And I named these. This one's called Fig, and then the FFT is called FFT_Fig. So I can save a plotly figure as an image, but also I can save it as an HTML file, so I could send it to somebody. They don't need Python. They can open it and they can interact with it.
Yeah, it's very cool.
So we'll do fig dot, we'll write an image first. So it's underscore dot write image. We'll say time history dot png. There we go. That will save an image, but I also want to write HTML. Time history dot HTML. I'm also going to pass in this parameter called include plotly.js equals CDN. I'll explain what this means real quick. If I don't pass this in, the HTML file is going to include the Plotly JavaScript library that makes it interactive. If I say include plotly.js equals CDN, I don't know what the CDN means. Well, I know what it means. I don't know what it exactly stands for. But what it means is reference the online hosted Plotly library.
Right.
So your HTML file is smaller. So, but if you don't need to pass this in. It will just include the whole library inside the HTML file. Actually, yeah. Which will make it 300 or 400 megabytes larger than it needs to be. Okay. So we have that, and we're also going to save the FFT and do it the same way. And if we finish this, if I refresh up here, I should see these, and I'll export this. I don't know the way this, if I open this in another tab here, I don't know if the video is going to come through, but let's find out. We'll keep talking anyways. Hopefully you guys can see this. Here's the FFT that we just exported, and you can follow along as well. So with that, what have we done here? We have shown you how to use Google Colab, install some libraries, load in some data.
That's right.
Do some time history plotting, quick frequency analysis, and how to share it.
That's right.
Did we miss anything?
No, I think that covers everything. I mean, that's pretty. Tried to keep it a little shorter, but it's a pretty quick overview.
Yeah.
Use Colab.
Well, hopefully you enjoy that. There's a ton of more video content we have on all this. It goes a little bit deeper on how to do FFTs, how to analyze long time histories, how to do this locally and not in Google online in the cloud, but maybe in Jupyter or in Spider on your computer. So hopefully this is helpful though, and you can use it to analyze your data, whether it's data from our devices or whatever other data sets you have.
Yeah.
All right. Enjoy.
Thanks.